Hello and welcome. In this video, we're going to talk about resistive and conductive materials. Resistive materials resist the flow of electrons. And so we'll see that that is our current, right? It'll slow down our current flow, which means that it opposes the current flow in our electric circuits. We're going to measure this in ohms. We'll give it this little ohmic value symbol here, and it's going to be measured using an ohm meter. And we're going to represent it as R in our mathematical equations. So we'll say that R is equal to, and that's going to be the total resistance, or the resistance across a very specific component is equal to. We'll also have conductive materials. Conductive materials are what we're going to make our wires out of, and they are going to readily allow current flow to pass through them. Right? So we're going to characterize resistance, the impedance of our movement of current, as resistance there, and our opposite side of that coin is going to be our Siemens, or our conductive materials here. So we can say that G, our conductive material, is equal to 1 over R, our resistive material, which means that they are inverse of each other. It's two sides of the same coin, right? Every single component you have has a resistive value and a conductive value, and they're just going to kind of balance each other out. If it's more resistive, it's going to be less conductive, and if it's more conductive, it's going to be less resistive. So we're going to have insulators, that's going to be our resistive values. We're going to have conductors, that's going to be our non-resistive values. We see that based on these numbers here. Insulators have a very high resistance in terms of ohms over a certain length of meter. And we'll see that that falls into the quartz and silicone range. Those ones are going to be a higher resistance. We could very quickly fall into the semiconductor stage, though. From times 10 to the positive 6 to times 10 to the negative 6, those are going to be the semiconductive range. Those are going to be the ones that we're going to mix together with other components to make them less or more resistive. And so those are going to fall into this center pattern right here. After that, we get into conductors very quickly. We end up at, from here all the way up to ones that we're very familiar with as conductors. We see silver, copper, gold, aluminum, zinc even. Zinc was the one that we used for that salt battery. Right? So those ones are going to be a higher conductivity. They're going to have less resistance overall. All right, and let us know if you have any questions.